Okay, welcome back. Last time we did all of these graphing of these different functions, right? They all are derived from the x squared, okay? Let's see if we can still identify them, okay? Can we still identify them, okay? Let me make this 125%. Okay, so we can see the whole picture. Do you guys see the picture all right? You can see the picture all right. So this is the x squared, right? This is x squared. Right? And this red one, maybe I should be using a different color. Okay, so this is x squared. Okay, so let's mark these together. Let's mark these together, okay? That's x squared. How about this red one? What is this? It's a negative x squared. Right? So all the output, right? That was positive before. Hold on. Okay, that the output before on this point. Okay, every point on the x squared. Now, when we look at negative x squared, it becomes its opposite. Opposite, negative sign, opposite. So the output opposite. Okay, the opposite of the output. So these two have opposite outputs for the same inputs. For the same input, they have the opposite outputs. Does that make sense? Okay. And next, let's look at the green. Let's look at the green. Okay, what is the green? The green is 2 times x squared. Okay, we plotted the points and we saw what happens. Okay, it becomes thinner compared to x squared. And next, last but not least, this color right here. And this guy is half of x squared. Does everybody follow me? That's what everybody did, right? What you should, well, what you are highly recommended to do is that you have plotted all of these points by yourself. Have you done that? If you haven't, I highly recommend you do that. And today we're going to continue this journey of, seeing the rules, the functions, and the consequence, right? All these different functions, because we modify the functions or for different functions and how they're related, okay, graphic wise and domain wise. And in terms of domain, they all have the same domain, all real numbers. By range, however, okay, so let's look at the range. Let's look at the range. Okay, let's look at the range. So domain wise, no problem. Okay, domain wise, no problem. So let's look at the range. Domain for all of these functions. All real numbers. All real numbers. Now, let's look at the range. Let's look at the range. The range for x squared, and we already know that. X squared is going to be greater than, well, it is greater than equals to 0. How about 2x squared? 2x squared is also greater than equal to 0. Half x squared, the range is also greater than equals to 0. You see the convenience of actually using inequalities. How about for negative x squared? Negative x squared, however, we multiply the inequalities on both sides by -1, is going to be less than or equal to 0, just like the picture have told us. Okay, so that's the domain and range perspective. Domain range perspective. I'm waiting for you guys to write it down and look at the picture from the input-output perspective, and we can see all of these. We can see all of these. So far, so good. We're going to move to the next part of these graphing. And of course, I'm going to rewrite this in nicer fonts. Okay, my handwriting with the mouse is not super good. At least it's not to my satisfaction. Okay, are you ready? Okay, mark all of these yourself. Even though I mark it on the picture, I'm not completely satisfied with the writing, but I don't have other options. So I write it, I rewrite it by these, okay, by these colors. By these colors. So far, so good. Did you finish writing? Did you finish writing these down? Let's see the chat. Chat says, yeah. Good morning. Does that mean you have written it down? Okay. All right. So I'm going to clean the board. I'm going to clean this up. Okay. I'm going to rewrite this for you. Okay. So let me see if I can put a domain here. Okay. So in terms of domain and range, as you look at the picture, right? For x squared, negative x squared, 2x squared, 2 times x squared, half x squared. Domain, all real numbers. No exceptions for all of these. All the same, right? So horizontally, the curve, the curves span indefinitely in both directions. Range, however, x squared, we know that it's a greater than equal to 0. Okay, and you multiply by 2, it's still greater than equals to 0. So 2 times x squared is greater than 0. Oh no, I'm sorry, I put it in the wrong place. Okay, 2 times x squared is greater than or equal to 0. And if you change that 2 to half, you multiply by half, it's still going to be greater than or equal to 0. Negative x squared, however, negative x squared, the domain is from negative infinity to positive infinity, the range is from will be less than or equal to 0. So you see that picture opens down, and touching zero. So that's what it means. That's what it means. Do we have any questions so far? We did all the graphing, we did all the tables. And if you have any questions regarding how those points are plotted, you can either ask me now, or you can look at those look at that lectures, you know, review the lectures from last time. And today we're going to look at actually we're going to look at four other functions, still derived from here, from x squared. Okay, and we're going to do some, I'm asking you guys to roll up your sleeve and do some plotting. Okay, roll up your sleeves and do some plotting. Okay, and we're going to still start from here, from x squared. Okay, still start from here. But this time, I'm going to copy over here. Wait, sorry, that's not copy. I'm going to insert. Okay, insert two columns. Okay, and the output will change. The first one is g of x. Okay, and that's going to be x squared plus 1. And the other one, I'm going to call it h of x. Okay, minus 1. I'm going to see what's happening. If you look at the rule, okay, the rule of this function is after you square it, you plus 1. After we square it, we minus 1. Okay, after we square it, we minus 1. And let's see how those pictures will be different from the original picture right here. So our output, of course, we're going to have output G, output H. Okay, and we are going to use the same input. We're going to use the same input. You guys follow me? We're going to be using the same input. So next, I want you guys to calculate G for all of these input. Okay, -2, and so on and so forth. H, okay, so this is going to be -2. So you plug in -2. All right, and then you're going to make those points, of course. Okay, so you're going to have input output points, but this time it's going to be G point, G output. And of course, you know what to expect. And the other one would be for the H output. You guys know what to do? Let's do it. Let's do it. Okay, let us do it. -2 squared is going to be -2 times -2. So this is going to be equals to 5. Okay, and the next one, oops, G of -1, -1, and this is going to be -1, and over here is going to be a 2. For 0, this is 0, and that is 0, and that's going to be 1. And for 1, That's going to be 2. 2, positive 2, positive 2. That's going to be 5. And we're making these points. Input, output. Negative 2 is input, output is 5. Negative 1 is negative 1. The output is 2. 0, 1, 1, 2, 2, 5. Okay. And you're gonna work out work it out for H. For H. You guys have the table in front. Did you write down the table and working on it? Please do. So I'm going to take this picture. Okay. For simplicity, okay, I'm going to only work with 3 pictures. I mean, we put 3 pictures in one. We put 3 pictures in one. Okay. I'm going to plot all of these points in that picture. Are you done with H? Are you guys done with H? Yeah. Okay, take your time. Input, output. Input, output. Different rules. Okay, so let's plot the points together. How about that? Okay, so we're going to plot the points together. And wait a minute. I thought I have another picture with. Okay, I think I want this picture instead. I want that picture with all the. Oh. Okay, I don't have it. Well, I guess they're all overwritten. But anyway, so I'm gonna make, look, I want you guys to start plotting. Okay, I want you guys to start plotting. Okay, I made some adjustment here on this picture. Okay, I made some adjustment here. So now I'm gonna plot. Okay, plot these points. And of course, I'm gonna use a different color. I'm gonna use different color. And let's see what color we're gonna use. Green. Okay. And another point is -1, and so this is gonna be 2. And 0, 1, 1, 2. Last but not least, 2, 5. All the green dots. Okay. And if we connect the dots, what do we get? X squared plus 1, and we make it green. You see, for the same input, every output is added 1. Every output on the X squared curve added 1. So the entire curve shifted up by 1 unit. You guys see that? Does everybody see that? I'm going to make it just a little bit lower. Okay. Every point. Okay, so let's see. Every single point. Okay, so if I draw a vertical line arbitrarily, okay, there's a little shifting taking place. So this is shifted. Hold on. Actually, let me erase all of that. Okay. There's a shift. Okay. This shift. You guys see that? Do you guys see that shift, that vertical shift? You guys see that vertical shift? What do you think that vertical shift is? How much is it? 1 unit. It's x squared plus 1. If it's x squared plus 2, it was shifted up by 2 units, right? If it's x squared plus 10, it will be shifted up by 10 units. Do you guys follow me? Okay, that's the shifting. That's the shifting. Okay. Can you guess? Can you guess for x squared minus 1? What will happen? What will happen? Any comments? So let's plot the other points. Okay, for the H. Okay. For the H. And we're gonna use, what color we're gonna use? Let's use red. Okay, we just have 3 colors. Okay, and the next one, we're gonna have 0, 1, 0, -2, 3. Okay, you can see when we work on the H, the dots are shifted down by 1 unit. The dot is shifted down by 1 unit. Okay, so let me use the shifted down by 1 unit. Let's clear it all. Okay, when we use it shifted down by 1 unit. Sorry, it's thicker. Okay, But when we have that, we shift it down by 1 unit. Do you see that? Shift it down by 1 unit. Same input. Shift down by 1 unit. Okay, so if we connect the dots, if we connect the red dots, okay, which is x squared minus 1. That's what we get. Okay, let me change the color. Oh, sorry. Plus 1, minus 1. I'm going to make it red. There. Okay, so shall we mark these pictures? Okay, every point is shifted. Okay, I want you guys to study this, and I will have quizzes on these shiftings. Okay, I will have quizzes on these shiftings. You'll be asked questions in a variety of different ways. Okay, so now let's mark these. Let's mark these points. The black, okay, which is right here. The black. Okay, and what is it? This is x squared. Okay, the next one, the green. Okay, the green. What about the green? The green is, what is it? It's x squared plus 1. How about the red? The red is x squared minus 1. Does everybody follow me? That's pretty straightforward, right? You take care of the square, and after square, you add 1 or subtract 1. That will be shifting up or shifting down. So let's look at the domain and range, okay? I want you guys to mark all of these points on the graph, okay? Do you think you can do that without my doing it? For example, you mark these 3 points. You mark these 3 points. Okay, you mark these 3 points. 1, 2, 3. 0, 0 is already marked for you. How about this guy, the green? Can you mark this green point? The green point is 0, 1. So I'm going to use arrow. Okay, and the red is 0, -1. And that's the red. You can see these 3 points, okay? They are on each of their respective curves. They have the same input, different output. Why different output? Because the rule is different, okay? On the green is x squared plus 1. On the red is x squared minus 1. And on the black is x squared itself. And so this tells you the shifting, okay? And it's the same for these other points, for these other points. Okay, for these other points. Okay, so today's homework, you want to mark all of those points to see better for yourself. Okay. You know, sometimes people, a student ask me or ask some other people, how do I study? How do I study? As a student, you need, after class, you need to study the lecture. you don't hit the homework right away. You should study the lecture. Okay, I learned this the hard way. Okay, when I was in college. Okay, when I was in college, the first year was especially hard. Did I tell you I was the first generation in my family that went to college? Did I tell you? I thought I did. Okay. So attending college is very difficult because I don't have any role models in my family. Okay, and nobody told me how to study. Oh, okay, so now you know. Okay, I'm the first generation. Okay, first generation. My parents, they don't know anything about math. My father was he's in the army, and my mother never went to school. And so there's no role model in the family, no help. And we certainly cannot afford tutors. Okay. We were very, very poor. We were very, very poor. And so I was lucky enough. I went to college, and and I didn't have to pay tuition. My parents only have to support me with monthly stipend or monthly allowance for food. Okay, but I have to take the exam to get in. So once I qualify, I don't have to pay tuition. So that was a kind of deal. So you can say I was on scholarship of a sort, but really we didn't have to pay tuition. Okay. Because I qualified for that program. But anyway, long story short, then I was very focused. So after class, I will hit homework. I hit homework. And then I realized, gee, sometimes you can't really do the homework. Of course, my first class in college was actually calculus. Okay, it wasn't algebra classes. It was a calculus class. And then after class, during the class, I took notes and I thought I understood everything. And so after class, I hit the homework and I thought, okay, I'm going to get over the homework. So I can, because I have, we take multiple classes at the same time. So after this class and the next class, you have 3, 4, sometimes even 5 classes at once. So you have to allocate your time on these different classes. And of course, I want to get over the homework, right? But then I found that when I do the homework questions, and so some of those questions, I have no idea how to do it. Okay, so I was struggling. And later, I finally figure out. Okay, after class, I should not hit the homework. I should hit the lecture. I should, that's what I did. Okay, after class, I did not hit the homework. I hit the lecture. I try to go over the lecture over and over again. At that time, we didn't have a recording. Okay, everything just rely on my notes. So I will study my notes. Oh, hold on, I have to pick this. This is Dean. Hello, Marlo. I'm good. I'm teaching right now. Oh, yes, of course. I will do that. Thank you. Thank you so much. Appreciate it. Bye-bye. All right. So that's my I figured this out. And then I realized after class, you don't hit the homework, you hit the lecture. Again. Okay. So I will carefully study the notes. And I would do everything the teacher did in class all over again. Did you hear that? I did everything the teacher has done all over again. Sometimes, close book, close notes. Okay, the teacher did this in class. I'm going to try to do it all over again. Guess what? In a lot of the cases, when I did the same thing the teacher did in class all over again, all by myself, and in many times, in many cases, I cannot redo it. I thought I understood. I thought I understood. No, I didn't. Okay, sometimes we may be fooled by ourselves. We thought we understood. Because if I truly understood, I should not have trouble doing homework. You understand what I'm saying? So you do this back and forth, back and forth. You study the notes. The best idea, the best way, the most efficient way to do it is you hit the notes, you hit the lecture, you study the lecture very carefully, every little detail covered. If you do that, you have no trouble doing homework. If you have trouble doing homework, that means I did not understand the lecture. Okay, and this method of study carry me through college and carry me through graduate school. Do you follow me? And it works. It works. It just works. I have test driven it. Okay, but I'm sure each one of you have your specific way of study. I'm sure you do. But always try to be an observer of your study method and ready to adjust to adjust it when you need. Eventually you will develop an effective way to study. You will develop an effective way of study that works for you. But you cannot keep doing the same thing over and over again and expect to get a different result. Okay, so this change of study method in my study, it makes a world of difference. It makes a world of difference because oftentimes the reason we cannot do homework, we have trouble with the quizzes, is because we never really understood the lecture. And that's one of the major lessons I have learned in my college years. God knows how many years I was in college. 4 years undergraduate school, undergrad, and I spent 3-4 years in graduate school. Okay, I actually had 2 master's degrees. Okay, one in China, one in the United States. But anyway, so that's the method that carried me through. Okay, the only difference between you and me is I'm older. Okay, I'm probably your parents' generation. Okay, so I share with my experience how to get through college. That's what I do. That's what I do. And of course, you can say I get paid for it. Yes, I do. I get paid for it. Okay. And if you can just discover your way and using my method as a reference, use my method as a reference, it might be, I hope it's helpful for you. Okay, don't keep doing the same thing over and over again if it doesn't get the grade you want. Modify it, change it, adjust it. Okay, make that adjustment necessary. Okay, so what you need to do is that you go home after class, you're going to mark just like you mark these 3 points. You're going to mark all 3 points here. 1, 2, 3. You are going to see from the input output perspective and what it means. So I'm going to do one more for you and you're going to do the rest. Okay, so you see the red here on the red curve, and that is what is that? That is 2, 3. Okay, and the green there Okay, the green, and that is 2,5. And what's the black there? Can you guys still see is 2,4? You see the same input, the output is shifted. The output is one more or one less. So that will cause the picture to shift up or down. Does everybody follow me? There's nothing else to it, really. There's nothing else to it. These functions is just, you look at that picture, you know, every picture is worth 1,000 words. And that's how you discover those 1,000 words. And we're not asking you to discover 1,000 words, maybe 100 words. How about that? If you can discover about 100 words, sometimes it's really just 20 words. You have understood what you're doing right now. Okay, so it's all about input. So you can see I keep that theme consistent. I keep that theme consistent. The point is about just input, output, really. In the future, one day, right? You have accumulated enough wealth. Okay, so let me give you an example. Let me give you an example. I'm going to give you an example. I really want to give you an example. What kind of example I'm going to give you? Okay, right here. In the future, let's see if this is. Okay, hold on. I'm going to show you an example. Well, this, I'm going to change the site. Okay, I'm going to give you a Google. Okay. I'm going to show you a picture. Okay, just 1 second. I'm going to give you a picture, which is Coca-Cola share price, stock share price. Okay, I was trying to find you a picture about housing price, but it takes a while. So I'm going to show you this picture. Okay. Does everybody see that? Okay, this is 1 day's fluctuation of Coca-Cola stock price. Suppose I show you the 5 years. Does everybody see this curve? Have you seen this? Yeah. If you look at this curve, did you see that little dot? Do you see that dot? You see that dot? This dot over here. Yeah? What does that tell you? What does that tell you? It tells you that the red dot, that blue dot, that green dot, it tells you is a 59.59 or $60.13 on February 21st, 2020. Okay. If you consider the date is input and the output is the price, and that's how, of course, they make the chart so that they make it for us to humanly read it. But it's all really just about input output. Do you guys see that? It's input. The input is a date. The output is the price. Does everybody follow me? Input output. And you can see these phenomena, this mathematical way of presenting of doing the graph is very much used in daily life. Okay, So let me see. I want you to see the housing price. Let's see if I can get it. Okay, housing prices. Okay, Los Angeles. Okay, so one day, let's see, do they give us a curve? Okay, let me see if they give us a curve. This is LA, right? This is LA. You know where this is? Does anyone have an address? You want to check it out? Hello, are you guys there? Image. Okay, I'm gonna get your image. Okay, this is the image. There we go. Student housing prices in US at a record level. At record level. We have two graphs here. Do you guys see the graph? Do you guys see this graph?
Yes.
Okay. So there's certainly a legend. And this is a capture rate, and this is price per bed. Price per bed. Look at the blue. Price per bed right now. Actually, it didn't show right now. It showed up to 2019. Price per bed fluctuate. How do we read the chart? Input, comma, output. You follow me? The legend may vary because sometimes they want to make it easier for a human to read. So they insert a little program to make us, make us read it easily. Okay. But it really, this mathematics we learn here that's what it's all about. Okay. It's consistent with the human world, with our reality when mathematics is used. Do you follow me? So don't think of that this math it's not relevant to you. Math is relevant to every one of us, to our life, to our, prospect, and economic well-being. Okay, you really have to know the numbers. You really have to know the numbers. We all have to. Okay, and this doesn't mean I know all the numbers. I don't know all the numbers, right? If you ask me any question about stock market, I say, oh, I don't know. And I cannot give any educated, very good information because I didn't study it. But for you, you're interested in any aspect of the finance in this country or in the world, you have to know math. You have to know math. Okay. So without further ado, math is just a simplified way of doing it. So you must get over. Okay. So for those of you who are either proud or embarrassed about not knowing math enough, this is your opportunity to learn. This is the opportunity to learn. But anyway, without further ado, we have done these two functions, right? These two functions we've done in let's see, alpha 17. Next, I have two more for you to do, but this time we will be doing not only x squared, okay? We're going to be doing x minus 1 squared. You see the difference, okay? X plus 1 squared, okay? And we're going to also do x minus 1 squared. Okay, so here you see x squared plus 1 and x minus x plus 1 squared. So there's a difference in order. Does that make a difference in consequence? Of course, right? If you look at the difference between, these are definitely different, aren't they? Are they different to you? What's the difference between these? They will be different in picture. They will be different in picture, which we'll be working on it. Okay, so let's see what the difference between this guy and that guy. Differences between x squared and this guy. Okay, another differences I want you guys to understand. This is a minus. Could you guys tell me the difference? A lot of our students couldn't tell the difference. A lot of our students, this is a difference just algebraically, okay, from the functions perspective. So let me show you the difference. Okay, on this guy, or on this guy. Okay, so I'm going to make a little table so that makes it easier to transport. Okay, so for x plus 1 squared, and what it means is that you still have that input, and that input add 1. That input add 1. Okay, and the consequence of that x plus 1 is given to this other function and make it squared. So we take x plus 1 and square it. And then x plus 1 squared is out. Do you guys see that? So there's an order of operation there. Do you guys see that? The order of operation. So you do the inside first, and then you do the outside. How about this guy? How about x squared? X squared, you still have this input, but this input will immediately be processed by the square. Okay, it comes out x squared. And then after that, we take that output over here and we plus 1. And afterwards, you get x squared plus 1. Do they have the same output for the same input? In most of cases, different. Okay, you guys follow me? Do you guys follow me? A lot of people confused, okay? Number one mistake, a lot of people think these two are the same. A lot of our students think these are the same. They're not the same. Do you follow me? Let's look at some examples. Let's look at some examples. Let's look at some examples. Okay, we don't need this anymore. Okay, so now I'm going to insert some rows and I want you guys to work on them. Okay. Everybody? Okay, I'm going to give you the same input. Same input. And you're going to produce the output. Okay, so you're going to plug in here. You're going to plug in here. And you come back to tell me if you get the same output. You know what to do? So this will be 1. So 1 plus 1 is 2. So this is come out 2. And 2 is given to here. So that's going to be 2 squared. And over here is 2 squared. 2 squared, that's 4. Do you follow me? Does everybody follow me? Yeah? Over here, 1 is the input. So now the output is 1 squared. 1 squared is 1. So 1 squared is 1. 1 plus 1, that's going to be 2. You follow me? Are they the same? They're not the same, aren't they? Yeah? And what difference was made? The parentheses. Parentheses. Okay? So are you ready to try one more? I'm going to give you the input of 2. And everybody, please work on this chart. Okay, and you're going to tell me what is the output for x plus 1. You can do it algebraically if you want, really. Okay, I will show you the algebraic way of doing it. 2 is given to x plus 1. So you're going to do x plus 1 first, and you get 3. So here you get 3. And 3 squared is what? So here you're going to get 3 squared, that's 9. Over here, you're going to get 4. 4 squared plus 1, that's going to be 2, 2 squared plus 1, okay? So 2 squared plus 1, you're going to get 5. Does everybody follow me? So they are not equal. They're not equal. This is a terrible mistake. Okay? Okay? So these two are entirely different. And we just did the graph of this one. We just did the graph of this one. And for these two, the same thing. Same thing. Okay? So I'm going to make another table. Okay? And we're going to work this out. Work this out. Because this is also another very common mistake. It's a very common mistake. Okay? And the idea is pretty much similar, except it's x minus 1. Okay, so this is x minus 1, this is x minus 1, this is x minus 1, this is x minus 1. And over here is very similar. Okay, except this is minus and that's minus. Okay, so once again, I'm going to give you some examples. Did you guys get a hang of it? Or this is just, this is too easy for you? Is this too easy for you, you guys? Yes or no? Or this is helpful for you? Is this helpful for you? Could you guys say something? Helpful? All right, different function, right? So next, I want you guys to go through this process all over again. Okay, I'm going to give you 2 input. Okay, so you don't have, this doesn't have to be very difficult, just 2, 1, 2, number 1, number 2. And you're going to produce the output for me. 1 replace 1, 1 minus 1 is 0. So this part is 0. 0 squared is going to be 0. So this one is going to be 1 minus 1. That's going to be equals to 0. On this other one, however, okay, you're going to take the 1 and you square the 1. You get 1 squared. 1 squared minus 1 is 1 squared minus 1 equals to 0. Ah, they're the same now. But are they same? Are they the same always? Remember mathematical truths. If true, it has to be always true. False once or false. Just because they're the same once, it doesn't mean they're same always, right? So let's look at the next one. Okay, so 2, x is 2. So in the end, you get 2 minus 1 squared. So you're gonna get 1. Over, you have 2 here, and what you get here, you're gonna have 2 squared. That's equals to 3. So they're not always the same. Do you follow me? So these two expressions, it's another mistake to think that they're the same. They're not. Okay, so that's a mistake. Very common mistake. Okay, very common mistake. So we have resolved these algebraic issues. We have resolved these algebraic issues. And there's a more aspect of algebraic issues here. Okay, so algebraically, x plus 1 squared is going to be what? If you FOIL this, do you guys know how to FOIL this? So this is the function perspective. Could you guys FOIL this? What do you get? What do you get? What do you get? FOIL that. FOIL that. You should get x squared. Look. Plus 2x plus 1. Telemarketer. Okay, if you FOIL this, x plus 1 squared is x squared plus 2x plus 1. And the other side is x squared plus 1. There's an extra term. There's an extra term. Okay, so this is correct. Okay, and you may like to review this in your elementary algebra class. Is that from your elementary algebra class, is a plus b squared is equals to a squared plus 2ab plus b squared. Have you guys seen that before? Well, if you made it to in intermediate algebra class, you probably have seen that. But if you have forgotten, and that's what it is. Mistake, correct, correct. You follow me? So this is we have the function perspective, and we have the formula in mathematics, okay? Let's look at these two. Let's look at these two, okay? Algebraically as well. Algebraically. Can you FOIL this for me? Can you FOIL that for me? Could you foil that for me? Do you know how to foil? Do you guys know how to foil? Does everybody know how to foil? If you find these things we're doing in class right now is helpful, that means you're not just taking one class. You're really taking 3 classes in one. Okay, you're taking intermediate algebra, you're taking elementary algebra, you're taking pre-algebra all at once. Okay, you're taking 3 classes in one. Okay, so this is x squared minus 2x plus 1. Okay, so this is true. Okay, so we first take care of these minute, not unimportant details, very important details. These are the building blocks of algebra. Okay, we build it little by little using the 6 principles. Okay, using the 6 principles. Okay, so that's the algebraic perspective about these. Okay, we have done x squared plus 1, and we have done x squared minus 1, and we saw the pictures. So let's look at how would we graph these two, right? How do we graph? Graph. And the other one. And this time we're going to make 3 different tables. We're going to make 3 different tables, okay? And of course, the first table is still this guy. Okay, and the second table. The second table, I'm going to make adjustment for you on these inputs. It's going to be about G and H. Okay, so one is X plus 1. And the other one, so this is going to be G. And the next table, and you're going to work with me together. Okay, you will have that opportunity to work with me, and you're going to do your okay, you're gonna be doing your work with me. I'm holding your hands, so hopefully this will be helpful. And these points will have to be adjusted. So right now, I want you guys to write down the first table all over again. The first table all over again. Okay, and I will give you new input. I will give you new input. Okay, new input. Examples of applying the new input. Okay, so we put a -3 here. -3. And we evaluate it. Okay, -3 plus 1, we get -2. -2 squared is 4. So this point is going to be -3, 4. Okay, likewise, on a different rule, x minus 1 squared. On -1, you remember, I'm this time the input is slightly different. Okay, So I'm going to give you negative. I give the first one is -1. So this is -1. So -1 minus 1 is -2. -2 squared is 4. And here the point is -1, comma 4. So do you guys know what to do? You are going to fill these up. You're going to fill these up. Do that for me? And then we're going to graph together. And we're going to plot those points together. So please write down the table and work on your table. Leave enough space on your notebook. Leave enough space on your notebook, please. How do I do this? I think I'm going to separate the table just a little bit. Okay, so that way we can see the table all on one page. Is this better? So you have the table for x squared, input, output, okay, G output, H output, all these are different functions. We're going to have 3 more curves. We're going to have 3 more curves. Oh, 11:45 almost. We'll take a break. We'll take a break. How about we take a break? Let's take a break and you can continue to work on these. We're having fun. While we're having fun, time flies, right? Back at 11:54. Let me give you 1 more minute, 55. Okay, so I'm going to pause the recording. Okay, guys, come back. Did you finish the points? I haven't finished. If you finish, you can start plotting, okay, in the same picture, in the same picture. All right, did you guys get all the points? Yeah? Did you guys get all the points? Let's plot. Let's plot. We're gonna plot all three. We're gonna plot all three in the same picture. Okay. Let me grab my old picture. Okay, so let's see if that will fit here. Well, I'm going to put it under. I'm going to put it right here, in between. How about that? Right, and the dots, I'm going to make it a different color. Oh, I should have saved that, didn't I? I should have saved that. Last one. Okay, so I'm going to save this picture for future. Okay, let's come back. Plot these points. G, x plus 1 squared. Okay, we have all of these points. We have all of these points. Okay, and we're going to plot points. Okay, let's see what color. What color do you like? Green? It doesn't really matter. Okay, the next point, -2, 1. The next point, -1, 0. 0, 1. And one more point, 1, 4. Do you see the red dot, the green dots? See the green dots? But what if we plot, we connect the dots? What do you think we're getting? Green. See that? Did you guys see that? Is that what you got? Did you get that too? Okay. Let's look at x minus 1 squared. Let's look at x minus 1 squared. Okay. So this time, it's -1, 4. We're going to use red dots. 0, 1, 1, 0, parentheses. 2, 1, last 3, 4. Red dots. Connect the dots. Connect the dots. Red. Boom. The black one. The black one is x squared. Okay, so let's mark them together. This guy is x squared. Okay. The red one is x, oops, I need the red color. Okay, red color. X minus 1 squared. The green. The green is x plus 1 squared. Did you guys mark that? Please, did you please mark that in the picture? And you also let's also look at the points. So you may start to understand how I have chosen the points. How do you think I have chosen the points? Right? Because this time the inputs are different. How have I chosen the points? You may wonder, right? You should wonder. You should wonder. If I were you, I would wonder too. How come my teacher knows that? Why did she choose the point the way she did? Yeah. Any idea? Hmm. Okay. All right. I think this marking is better. Please, could you please write it down? So what have we seen? We see the shifting, right? We see the shifting. We see the shifting. How does it shift? If it's x plus 1, it's shifted to the left, right? If x plus 1 is shifted to the left. Okay. So it's shifted to the left. Otherwise, if it's x minus 1, is shifted to the right. And the shifting is horizontal. The shifting is horizontal. Horizontally shifting left or right. And the difference is that this is x plus 1, this is x minus 1. X plus 1, and then square, you shift to the left. X minus 1, you shift to the right. Make sense? Now, let's look at how much is being shifted. How much is being shifted? From the black to the green, the shifting is horizontal. How many units do you think? How many units do you think that is? How many units? 1 unit. 1 unit. Horizontal, 1 unit. 1 unit. Okay, every point. This is about every point. Okay, every point. Shifted one unit to the left. Okay, from x squared to x plus 1 squared. From x squared to x minus 1 squared, the red is shifted 1 unit to the right. 1 unit to the right. Every point shifted. Okay, 1 unit to the right, horizontally. Does everybody understand? Now, we have done all of these pictures but one. Okay, there's a last one. Last one we're gonna have to spend a lot of time on after this. Okay, so let's summarize. Okay, I'm waiting for you guys to write it down. I'm waiting for you guys to write it down. Okay, we're gonna summarize. We're gonna summarize. Are you done? Are you done writing these down? Does that make sense? So if I give you an x plus 2 squared, can you do that? X minus 2 squared instead, x plus 2 squared, and you know which direction it shifts, right? Left or right, and so on and so forth. Ready? Okay. Let's summarize. What have we done since last time? We've done this shifting. This is what we did recently, most recently. Okay. And what else have we done? Just before this, we did that. Okay. And yesterday, no, on last Monday, we did this. We did this. Okay. So let's recap. Let's recap. On this picture, okay? I'm going to make it larger. I want every one of you to remark these pictures. Okay, yes, there are some clues and on the picture, but I still want you to remark these pictures. Reflect on what we've done. Okay, reflect on what we have done. This is x squared. Okay. Negative x squared. Two x squared. Half x squared. Got it? Yeah. You want to make sure that after class you've done it by yourself for yourself. Okay. You've done it by yourself for yourself. You make sure you do it by yourself and for yourself. Because I'll be giving you some questions. Okay, you'll be having some quiz questions based on these. Okay, in terms of shifting, left and right, so on and so forth. Now, we've done that. Clear all? We just mark these, right? We need to mark this again. Let's do it again, right? Let's do it again, right? For the fun of it, for the fun of it. If you understand these pictures, you understand a lot. You have understood a lot, okay? The red, let's do the black. The black, okay? the black, this guy is x squared. The green, should be this guy. Okay, the green. What is the green? Can you guys tell me? It's x squared plus 1. Okay, adding 1 after the square. Adding 1 after the square. And the red is x squared minus 1. You do that all correctly with all the understanding. Okay. Last but not least, okay. We know we just marked this, but just in case. Okay. X squared, the green, this is a place that people tend to get confused. Okay, and the red. And of course, we have marked all of that. So far, so good? So far, so good? Okay, so now I'm going to give you some questions. I'm going to give you some questions, okay? Do you think you understood this? Very good. Let's test drive it. Let's test drive it. Okay? We don't want to be fooled by ourselves. Okay? With all of these said and done, I'm going to give you something like this. I just put some random numbers there. How would this picture look like? How do we make this picture? Of course, you can plot points, right? You can plot points like we always do. How is this picture look like from this basic picture? Right? How you're going to shift it, how you are going to shift it, and where to shift, and where will be the, the lowest point or the highest point. We call this a vertex, okay? Vertex, this point is a vertex. The highest point or the lowest point is called a vertex. Okay, vertex. Okay. To get this picture from that, okay? And the first thing we do is we go from x squared to, we follow the order of operation, okay? We follow the order of operation. So from here to here. Okay, so the sequence of movements. Okay, and from there, we're going to do Hold on a second. I need that original function there. Okay. From here, we're going to do this 3 times. Okay. And after 3 times, we'll get to the whole thing. We'll get to the whole thing. Okay. So let's see how we move this about. X squared is shifted to from x squared to x minus 2 squared. How is this shifting? How is this shifted? Before you see the picture, where do you think x from x squared to x minus 2, where will this be shifted? Is this shifting horizontal or vertical? Left or right? Left or right? Put in your best guess. Okay, I'm not going to go to your house and check on you if you get it right. Okay, this is just some kind of self-check. Okay, if you want to make your guess public, that's amazing. Okay, we'll share that. So what is your guess? From x squared to x minus 2 squared, is this shifting up or down, left or right? Could I see some feedback? Could I see some educated guess? No one says anything. Some people have left. Okay. If you guess it's going to be shifted horizontally to the right by 2 units, you're right. Okay, so let's, you see, shifted to the right by 2 units. Okay, it looks like I need to make a little adjustment to the, okay, so it's shifted to the right by 2 units. Okay, that's the second movement. Second movement. Third movement, multiply by 3. Multiply by 3. So this picture, multiply by 3. Is the picture going to be thinner or wider? Is it going to be thinner or wider? Okay, so let me make sure you have a proper comparison, points of comparison, okay? Is it going to be, after we multiply by 3, what will happen? Is it going to be thinner or wider? What do you think? Huh? Is it thinner going to be thinner or wider? We multiply by 3. And it's going to be, what color did I use? I used green. So I'm going to use red. Wider or thinner? Thinner. You see? Thinner. Right? And then the whole thing, add 4. So is it going to be shifting to the left, right, up, or down? What do you think? We're making cartoons, right? We're making cartoon of sort. Okay, so the final picture will be, we shift oops, sorry. Okay, the final picture, we will shift up or down. The final picture, I'm going to use, let's see what color. I'm going to use purple. We shifted up by 4 units. Is this clear, everybody? Is this helpful? Is this helpful? Do you want to try one? Do you want to try one? And now, what is the vertex? What is the lowest point? The lowest point obviously is what? It's 2, 4. Okay, so vertex is 2, 4. 2, 4, which is right this point. Okay, they happen to overlap. Okay. So far, so good. Do you want to try one? Okay. So I'm going to give you another question. Your turn. Okay. So this other function I'm going to give you, I'm going to call it G. Okay. 1/2. Describes the sequence of movement. Describes the sequence of movement. We done? Are you done? Yeah? All right. So your sequence of movement. So let's see, what is your sequence of movement? So the first one, of course, is x squared. And the next one is what? X plus 3 squared. And then what? Half. Right? And last but not least, shifting. So all of these represent a movement using what we just learned. Okay. So from x squared to x plus 1, x plus 3 squared, that is shifting to the left by 3 units. Okay, and this one, after the shifting of 3 units to the left, multiply by 1/2, the curve is going to be wider. The vertex stay the same place. And then -1, the entire curve shifted down by 1 unit. Shifted down by 1 unit. Do you guys follow me? Yeah? So the first picture, okay, we started from there. Okay, I'm just going to make a little adjustment. Oh, sorry. A little adjustment for the beginning. This is a little bit. Okay, this is make it -3. This is 5. This is -8. Okay, so I think this will be better. Okay. I made the adjustment so that it makes it easier to compare. Okay, I try to use the same scale. So the first movement, x plus 3 squared. So when we make that shifting, the original picture will be shifted to the left by 3 units. So that's x plus 3 squared. Now we're going to use green. Shift it to the left. You see the vertex will shift from 0, 0 to -3, 0. Okay, -3, 0. And next, okay, it's multiply by half. Okay, multiply by half. So the next movement, okay, we take this picture and we multiply by half. And we recognize it's wider. This curve is going to be wider. And we're going to use a red color. So okay, you see the red one is wider. This is after multiply by half. And last but not least, okay, the last movement is we take this picture and we shift it down by 1 unit. Shift it down by 1 unit. Okay, so the final picture, we're going to still use the purple. So could you tell me the vertex? What is the vertex here? Give the vertex. May I see some answers on chat? May I see some answers on chat? May I see some answers on chat? Do you have any questions? Do you have any questions? No question. Okay, if this is easy, this is easier for you, that's no problem. But what is the vertex? Do you have any can you identify the vertex for me? This lowest point, what is it? Can you mark that vertex? I will be quizzing you. I will be quizzing you. Yeah? What will be that vertex? What is that vertex? Come on, guys. After all those shifting, after all those shifting, where is the vertex? Hmm? No answer. Come on, guys. Come on. Come on, guys. Please. Come on, guys. No answer. You guys are sleeping? What is the vertex? Tell me, what is the lowest point here? What is the lowest point here? It's going to be in the quiz. Of course, similar questions. Hmm? Similar questions. Hmm?
-3, -1.
Very good. You got it. Okay. -3, -1. You can see from this form, don't you? You can see from this form, -3, -1. So it's, if this is easy for everybody, that's great. Okay. But we do want to summarize some stuff. Because next, okay, we're going to take all of this we have learned now, and then we're going to look at this ultimate quadratic function, which is ax squared plus bx plus c, where a is not 0. Okay, a is not 0. We're going to study this function from what we have seen, when a is -1, right? Negative x squared. When a is -1, we have seen a is, for a, okay, we have seen these cases. What are these cases? Negative x squared. Negative squared means what? In this case, a is -1. The parabola opens up or down? Opens down. Okay, we have seen cases such as x squared, right? And we also have seen 2x squared. And what else have we seen? We have seen half x squared, right? We have seen half x squared, etc. In all of these cases, in this case, a is 1. In this case, a is 2. In this case, a is half. But they're all positive, aren't they? In all these cases, when a are positive, the parabola opens what? Which direction the parabola opens to? opens up. Okay. Then you say, how about A is zero? A is zero. No, A is not allowed to be zero if we are considering parabola. So that's this requirement. Okay. So from these examples we did, we can safely say that if A is larger than zero, parabola opens up. If A is less than zero, the parabola is not opening up, it opens down. Does everybody follow me? Yes?
Yes.
The next one, okay? The parabola we have seen here, okay? We've seen all of these parabolas, right? You can see all of these, they have some kind of symmetry. It's symmetrical with the y-axis. And these parabola, this final purple one, okay, this final purple one, it is symmetrical, but not symmetrical with respect to y-axis. So it seems that every parabola has a symmetry, has a very special feature, okay? Every parabola is symmetrical with respect to a line of symmetry. Okay, a line of symmetry. This line of symmetry is to be determined. Okay, this line of symmetry is to be determined. In some cases, the line of symmetry is just the y-axis. In some other cases, the line of symmetry actually is moving about. Okay, it's not there's not a fixed line of symmetry. So in a lot of situations, we want to identify that line of symmetry, but we might be able to identify some patterns. Okay, so what is a line of symmetry? So how do we identify the line? How to identify the line of symmetry? Okay, so let's see if we can learn something from this process. Okay, let's see if we can learn something from what we have done. Okay, today I'm not going to do a lot of new things. I just want you guys to look at what we have done to discover. For example, okay, in the early days, on this picture, right? What is the line of symmetry for all of them? What is the line of symmetry for all of them? You guys follow me? What is the line of symmetry for all of them? It's y-axis, right? It's y-axis. So what are these functions? We have x squared, right? We have 2x squared. You don't need to memorize. You really don't need to memorize, right? 2x squared, half x squared, right? And what else? Negative x squared. What do they all have in common? They just have x squared alone. Okay? You can view them as x minus 0. You can view them as x minus 0. You can view them as x minus 0 for all of these. X minus 0 is the same as x. Okay? But I'm trying to make a point here. I'm trying to make a point here. You can say it's plus 0, minus 0, it doesn't really matter. It doesn't really matter. The thing is that it's just x plus 0 or minus 0. The line of symmetry is what? What is the line of symmetry? The line of symmetry is y-axis. What is the equation of y-axis? For all of these functions, for all of these quadratic functions, the line of symmetry is y-axis. But what is the equation? And what is the equation? What is the equation of that y-axis? The equation is x equals 0. Do you guys follow me? This is the line of symmetry. I know it's kind of hard to understand, okay? When I was a student, I have a hard time understand it too, okay? The line of symmetry is y-axis, all right? But how come the equation is x equals 0? How could that be? Does anyone have a question about that? Yes or no? No. Oh, okay. If you don't have any question, that's no problem. That's great. Let's continue the observation. Let's continue the observation. What else have we done? We have done these. Okay, we've done these. Okay. What is the line of symmetry for these three? When we shift up or shift down, does it change the line of symmetry? When we shift up or down, it doesn't change the line of symmetry, doesn't it? It doesn't change the line of symmetry when we shift up or down. Okay. Do you agree with me? When shifting up or down, the line of symmetry stays the same. Okay. Do you agree with me or not? Okay, I assume you do. Last but not least, what happened to these line of symmetry? What happened to these line of symmetry? Obviously, we have different line of symmetry now, right? In all of these cases, the line of symmetry, they're all the same. They're just y-axis, which is x equals 0. Now let's look at these three lines. Can you draw the line of symmetry for the green, for the red, and for the black? Can you do that for me? I want you to have a piece of paper, write it down. Okay, what we are observing right now is going to be very, very useful. Okay, for next week and for the future. Okay. The green line of symmetry. Okay, and now I'm going to draw the red line of symmetry. Red. Broken line, please. Broken line, line of symmetry. You can see when we shift horizontally, the line of symmetry will shift it along with it. Does that make sense? Shall we write it down? So when we shift, so when shifting left or right, the line of symmetry shifts. Left or right, left or right. By the same number of units. By the same number of units. Do you agree? Right? What did we do before? The green is shifted from the block by 1 unit. The line of symmetry is also shifted by the same number of units. You guys follow me? The green, okay, is shifted by 1 unit. The line of symmetry is also shifted by 1 unit. Same number of units shifted. If we shift it to the right, the line of symmetry will also shift it to the right by the same number of units. Does that make sense? Okay, now the red is also shifted by the same number of units. So the line of symmetry shifted along with it. Now let's see what are the line of symmetry. What is the line of symmetry for this green broken line? What is the line symmetry for this green broken line? And that equation, green is x equals to -1. The red, okay. Oh, it shifted red, gosh. No. The green, I want that to be the green. The green line of symmetry, right? Well, we shift to the left by 1 unit, right? And what do you see? The equation is going to be x equals to -1, right? This line is x equals to -1. Okay, let's look at the red. Okay, the red is the consequence of the black one shifted to the right by 1 unit. And that equation is x equals to +1. Now, I want you to see what is the curve equation for the green. The equation for green, is x plus 1 squared. You guys see some pattern here? Do you guys see some patterns here? The red is x minus 1. Does everybody follow me? So if it's x minus 1 squared, the line of symmetry is x equals to 1. If it's x plus 1 squared, the line of symmetry is x equals to -1. Excuse me. Did you guys see that? Do we see patterns? So far, so good? Everybody? Now let's look at the 2 examples that we've done. Could I clean this up? Did you write it down? You see this, if you shift to the left, the line of symmetry, if you have +2, this is going to be x equals -2. If you have a x -5, this is going to be x equals to 5. Got it? Everybody? All right. You might be tired, but you're still trying to stay to the end. Okay, I really appreciate that. Now let's look at the examples we did. Okay, these line of symmetries, of course, they're all coincide with x equals 0. And then last but not least, okay, we have done 2 examples. Let's see, what is the line of symmetry? What is the line of symmetry in the first example? What is the line of symmetry in the first example? The line of symmetry in the first example is that we did x -2 squared, right? We shift it to the right, and then we made it narrow, and the x coordinate of that vertex stay on the same line. You guys follow me? This is the line of symmetry after we did x -2. And this is the still the same line of symmetry, isn't it? Still on the 2, right? And this is still the line of symmetry in the final purple. So what is the line of symmetry here? What is the line of symmetry in this case? The line of symmetry here is x equals to 2. You follow me? That's the line of symmetry. See, the line of symmetry did not move. When you do x -2 squared, that is shifting either left or right, and the line of symmetry has already decided. Does everybody follow me? So the vertex, the first number in the vertex actually tell you the line of symmetry. Do you guys see that? Okay. Yes. Now, one more thing. Last example we did. Okay, last example we did. Now, x +3. Okay, if we look at the sequence of movement, okay, when we do x +3, we shift it left to the right, we shift it left by 3 units. And the line of symmetry has never changed, has never left that place, okay? The line of symmetry stays there. And what is that equation? What is that equation? That line of symmetry, okay, stayed. We made it wider, we made it narrower, and that line of symmetry has not changed the x coordinate. So what will be the line of symmetry? -3. It's for x. Okay, so let me write it down. Line of symmetry. That line of symmetry is x equals to -3. Once again, you see on the vertex, the first number, the input tells you the line of symmetry is x equals to -3. So we had all these interesting observations, didn't we? Do you think we're ready to handle more complicated situation? Absolutely. Okay, that's where I'm going to take you guys to. And we are approaching the end of the class, and you should expect another quiz, and it's going to be about quadratic on Monday and today. Okay, Monday and today. These things we covered in class, I'm quizzing you. It's either available today or it will be available tomorrow. Okay, I will try to make it available today, but I have some meetings. You see the, I have some meetings and some other obligations from the department, but I will try to get it available to you today. If not today, I work tonight and make it available in the morning. Okay, but just wait for that message. I will send it to you. And meanwhile, study these topics. Okay, all these little details I trying to point out is going to be very, very useful for every one of us. Okay, so I will see you guys tomorrow, on Monday, if not sooner. And just remember, I have office hours tomorrow as well. So please don't hesitate to ask questions whenever you have one. Okay, thank you very much. We will see each other on Monday. Have a great weekend.